application, IIT Jamshedpur, and my supervisor is Dr. D.K. Yadav, Associate Professor, Department of Computer Application, IIT Jamshedpur. No, sir, I am MCA and currently pursuing PhD. No, sir, MCA. After MCA, I am, yes. And my research area is software reliability and quality modeling.
You are the full-time PhD?
Yes.
Which year you are running?
Sir, second year. Yes. My paper title is software defect estimation using matrix of early stages of software development life cycle. So here is the main thing is software defect estimation. So we all are know about that. In today life, everyone is directly or indirectly connected with software, computer software in every area. For a day-to-day life to the higher level, that is in military services, aircraft controlling, everywhere. So in the high level, that is in military or air traffic control or in military services, if the chances of software quality is low, then there is a very high risk for danger of human life death. That's why our software should be good quality and good reliable also. So for the reliability perspective or quality perspective, the defect estimation of software is very necessary. And so in this paper, I proposed one technique for estimation of a defect in early phases that is before testing phase. So that a testing team get from the predicted value or estimated value, they made a good plan in a controlled way and decide a better technique and test cases for software testing purposes. So these are some points which I will go through. First is abstract, then basic concept. Third one is proposed methodology, and finally experiments and result and conclusion references. So as I already told that my work is related to the early phases. So every software industry require early estimation of software defect for quality estimation, evaluation and testing resource planning. In early phases of software development, failure data is not available. That's why qualitative value should be taken for quality value. However, metrics of early phases of SDLC can be accessed qualitatively. In this paper, a software defect estimation model is proposed using qualitative value of 5 reliability relevant metrics, that is techno complexity, practitioner level, creation effort, review effort, and the urgency. We use a tool that is Bayesian belief network for creating a proposed model and for validation purpose also. The Bayesian belief network has been employed to build model dependent relationship of considered metrics. In order to validate the proposed model, an empirical experiment has been performed based on the data collected from the software development projects used by an software organization. The project is very small. The estimated defects were found very near to the actual defect during the testing phase. Some important points I will leave this page because everyone know about what is error, fault, and defects and failure. These are the diagrammatic representation of fault, defects, and failure. In every software, first fault introduced, the reason for defect discovered in product before release and after release, which are object as a failure. So there is a defect estimation process. First, we build the software. After that, we found there is a chances of defect. Then fixed the defect. Finally created. Again, after release, we found that there is a chances of defect, and that is the left in a software after release. The tools Bayesian belief network, there is some points regarding the Bayesian belief network. This is the one of the method for modeling system that include causal relationship among variable. This is the best method for analysis under uncertainty and in the presence of limited data. We already told that we predict the defect in early phases. That's why in that case, there is no data is available. So we use the early phase of matrices and the qualitative value of that matrix. The estimation based on the evidence propagation algorithm that dynamically update the model based on the current data. It can come together different data including individual blips and empirical data. It will provide estimation even if there is a partial or missing data is available. There is a proposed methodology, the process for defining the Bayesian belief network model. To define the Bayesian belief model, there is a need to identify the range of information and data source available and identify risky variables. In this model, we already said that there is a 5 factors, that is techno complexity, practitioner level, creation effort, review effort, and agency considered in this paper for the purpose of building the Bayesian belief network. Yes, sir. Risky variable, the chances through which the chances of software risk may be high, that is the chances of a defect maybe in the software high. As like
I don't want to explain this in terms of this.
okay, sir.
Okay, so
That is
one
the
more question,
when we want to develop a software,
talk about
so there is a software
availability
team,
and delay.
the software team experience,
So how will
the practice level,
get,
the effort in requirement gathering, the effort in coding. In that cases, the chances of the experience of software development team, the review effort, the requirement gathering time. In that cases, on the basis of the less or high or medium experience or review effort, in that case, on that basis, sir, we finally identify, and I don't have enough idea about that, sir. Steps as for designing for Bayesian belief network, based on the risk factor and their relationship, as already told, the risk factors about the techno complexity review effort, the graph model, then design the probability table for that all the factors. The probability table can be obtained through the different functional algorithm and by the domain expert. Then finally, assignment of value to the node according to the evidence obtained. 100% probability is assigned to the node in the directed cyclic graph, for which the evidence is conjugate. Evidence is the information obtained from the current project. So based on the above 3 steps, the probability for the 3 levels, that is low, medium, and high, can be calculated. These are the architecture of my model and their relationship, causal relationship, that is complexity, urgency, practitioner level,
Anyway,
effort of
so
SRT,
next
effort
time
at
we will
design,
go for
effort at coding.
another
Then according on the basis of the effort quality of SRT, quality of design, quality of code, defect found, fixed at various level, that is SRT and design and coding, and finally in the residual
your
part of
observations.
coding.
Okay.
The matrix description, techno complexity is the matrix describe the technology used for the software development and the
Next
complexity of
presentation
software
will be
requirement. The increased complexity lead to the
Kumar
misinterpretation about the product.
NIT Patna. And
So, sir, I didn't
title of the
compute.
paper,
Sir,
this
I
paper is
select the matrices and
hospital
the
length
software
of
development
stay
company, and based on
on
the
this presence.
expert experience, yes.
Have you computed any kind of complexity for the
No, sir. Already computed data are available in the company. I have only proposed the model. I designed the model, and based on the evidence from the expert, I apply these content to our model, and finally we get. No, sir, I don't. Yes, sir, I know about it. Yes, yes,
might have got data from common
yes.
but we should know which complexity measure is
Much,
Is
yes.
it still measurement, is it CMK,
Mm-hmm.
or is it cognitive?
Yeah, okay.
Because if you don't have complexity, you cannot at all define,
Yes.
design, develop.
Yes.
Right?
Yes, yes. I will go through that, sir.
I'm not reporting anything. I'm just
Yes, sir, yes,
for the
sir.
benefit of audience.
Yes,
For
sir.
the benefit of right.
Sir, I also benefited, sir, because this is useful for my work also, sir.
I see everything is,
No, sir, no, not at all,
I
sir.
want them to get something from their receiving.
I am also getting, sir, knowledge from your side. It's not problem for me, sir. Similarly, for creation effort, review effort, and the urgency level. These are the compiled mode of our model on the basis of the probability tables given in Hmm.
Did you develop the version network software, or are you using MATLAB, or which tool are you using?
So based and belief network already built by the other software company, is Netica. This is a tool. Yes, sir, yes. Okay, sir. Why not? Based and belief network is a concept developed by the Netica and Norway System Limited companies, and another one company is running by the Fenton. Norman and Fenton is a professor of University Queen Mary University, London. I used the tools which are developed by the Norway System Limited, Netica tools. Through these tools, we can design our proper model based on the factors and the variables, and design the causal relationship among among these variables, and then put the NPT node probability table in each and every variables. Finally, on the basis of the evidence which are obtained through the expert, we apply the evidence onto the model, and it will reflect all the models and calculate the probability values of the last variables. And this variable in the form of low, medium, high. Then based on the defects and the variation of defects is also in low, medium, high terms, then calculate the probability value to the defects low, medium, high value, and calculate the finally defect. We can calculate the, yes sir? Input, sir, these are the inputs. Specifications of the project 1, specification for project 2. Similarly, we develop for the project 3. Yes, sir, yes, sir.
This is the input to the project.
Yes, sir.
What is your margin that creates the clarity of the product?
Yes.
So who is specifying it in 5 million?
Yes, sir. Expert will decide the specification of the project's key qualities, the review effort, and the.
Then you only decide
Yes, sir. No, sir. As you told, sir. Yes, sir. Yes, sir.
just create one column analysis.
Yes, sir.
So that either they follow your step or don't follow.
Sir, they can follow, sir. There is a, sir, and yes, sir.
5 years of what is that?
SRD, sir, a specification requirement document.
You say high.
Yes, sir. It means the specification requirement document gathered by the team is very high level.
High.
Yes, sir, मतलब requirement gathering is a high level. मतलब उसने requirement जितना हो सका उतना gather किया.
That's good.
Yes, sir, good. Yes, sir. So that will decide by the expert how much a requirement will be gathered or not. I cannot describe the requirement because I am not doing my project. It's not my project. Project already handled, created by the development company. They have the data. They qualify the data. Yes, sir.
First, second, third, fourth, fifth, sixth, seventh.
Yes, sir.
After the sixth, I believe that expert can.
Yes, sir.
Seventh is
Urgency and standard time.
for completion or for start.
For completion, sir. See, how much time company will get?
How have you developed anything to find out the time requirement?
Yes, sir.
How do you find time?
That's why, sir, I am saying the INC label, that means if anyone wants the development of a software, that's why I am saying, sir, these are the software is very, small level of software, very small code.
Also go and bring this task force.
Yes, sir.
But you will follow certain steps.
Yes.
Calculate
Yes, yes.
how many light years I need to
Ye-
the
Yes.
You will either use your CPM first,
Yes, there is,
time of sequence diagram, or
Yes.
you will get it right.
yes.
Then you can say high CPM.
Because, sir, I am not doing in, on particular project, sir. I am only using the data. Yes. Yes, yes, yes. It is,
Then your data set really work out.
yes, sir.
Your data set.
Data sets, sir, there is a, I am working in a good way, that is a, Fenton data is already,
Any slide for
no, sir, in this paper, sorry, in this paper I didn't use and I haven't at that time, but I have the normal Fenton data, they are used. I am working on that data. There is a total 31 project data available for the different categories of variables, that is which Some of them I already used in this project. And based on the data available and the evidence of technical complexity, urgency and practitioner level, I apply that evidence to the models and calculate the probability value of fault finding in code. For project 1, similarly apply into the project 2 and for project 3. On the basis of the probability value in from the Netica models, from Netica tools, we calculated the faults. These are the actual faults which are discovered after the testing phase, and these are the estimated faults which we will calculate it before the testing phase. So these results show that we can predict the default before the testing phase if the qualitative values are available and the matrices are known. If any question then?
How many projects you have
Only 3. Yes, I am working, sir, total 31 projects data which are available in Norman and Fenton paper, which are published in 2008, Empirical Software Engineering. All the data are available in that paper. I am working on that paper, and I am near about to get a result in a good accurate way, which are already Fenton got. I am working on that, sir. Unfortunately, I didn't have a laptop and the data, otherwise I will show you that.
how you will decide the complexity of the
Yes, sir. As already sir asked me that question, that there is a different measurement of the decide the complexity of a project, sir. So I have to gain the knowledge about that also. Yes, sir. Based in belief network. Yes, sir. These are the future goals. I can compare the results getting from the Bayesian belief network and results getting from the fuzzy or a neural or artificial. I can compare that these are the parts of the future works which I will go through. Thank you.
Thank you. Next we have paper ID 66, Harikesh Bahadur Yadav.
Good morning to all of you. My name is Harikesh Yadav. I am a research scholar at Department of Computer Application, NIT Jamshedpur. The topic of my presentation is defect density analysis of early software development phases. Okay. I have done my MTech from BIT Mesra Ranchi. After that, nowadays I am a research scholar. No, sir. Sorry. I have done my BTech from BIT Ghaziabad, UPTU. Then MTech from BIT Mesra Ranchi. And nowadays I am a research scholar at Department of Computer Application at NIT Jamshedpur. Yeah, full time. Second year. Yeah. What's up? Yeah. Course was completed and literature survey almost over. Almost. The outline of presentation is introduction, proposed model, result and discussion, conclusion and references. In the introduction, I will basically discuss the reason for working in the field of software reliability and quality. Today, almost everyone in the world is directly or indirectly affected by the computer system. Computers are used in diverse areas of various applications like air traffic control, hospital management system, etc. A computer system consists of two major components. One is hardware, one is software. Although extensive research has been carried out on hardware reliability, the major focus has shifted on system software reliability. Because software plays an engaging role in computer system, software is extremely complex. Software reliability, not system software. Software failure occur frequently and safety critical software should be highly reliable as failure of this system may cause injury or death to human beings. Means software can kill person also. Due to this, software reliability analysis has become a major research area nowadays. These are some important terms. You know: error, fault, defect, and failures. In the SDLC phases, requirement phase, design phase, and implementation phase is known as the early software development phases. In the early phases of software development life cycle, matrices are emphasized. Therefore, an uncertainty modeling of early software matrices are required for early software defect prediction and analysis. Imprecise.
Based on what? The other document, legal data,
Matrices in the any phases, sir. In the early phases like requirement
all of
phase.
them are
Maximum are emphasized. This is a proposed model. In this paper, a model is proposed to predict the software defect indicator of early phases of software development life cycle using the topmost reliability relevant matrices at each artifact. In the requirement phase, the defect indicator is predicted using the requirement defect density, requirement specification change request, and the requirement inspection and walkthrough matrices. Similarly, in the design phase, along with cyclomatic complexity and design review effectiveness, the output of the first phase means requirement phase taken as input in the design phase, requirement phase defect density indicator. Similarly, in the coding phase, the output of the design phase means design phase. What, sir? Requirement defect density. No, this is in the one paper given by the Mr. Lee. He ranked the matrices according to their contribution in the software reliability. Yeah, this is my architecture. Okay. Okay. Input, yes, sir. This is the matrices in the requirement phase, sir. There are several matrices in the requirement phase. These are few of them, top three reliability. Yeah, I have taken three matrices of reliability phase. These are the three matrices. Requirement change request. There are several reliability matrices in the requirement phase. Yeah. Natural language means the value of the matrices are given in the form of. Okay.
Is this your natural language?
No, I didn't take the requirement specification. I have taken only the matrices in the requirement page only, and their value. What their value?
I cannot understand how to do it.
Actually, we have.
If you have RED before developing a software, there will not be any defect in any software there. And if that is possible, then Windows professionals would not have died. Windows really at that time. It died in 3 months. They spent billions of dollars in testing that.
Sir, actually, we don't have the data of requirement defect density. We have the data. If requirement defect density is high, if the requirement defect density is low, then what can happen? If in the requirement phase, requirement defect density is high, we have some imprecise value only. Similarly, in the coding phase, we have taken programmer capability and process maturity as input along with design phase defect indicator, and then we have predicted as coding phase defect indicator. Research methodology. The following steps are involved in the proposed model. First is selection of software matrix. Second step is define membership function of each input and output matrix. Third step is design the fuzzy rule. And fourth is the perform fuzzy inference and defuzzification. I use a MATLAB for fuzzy rule. First is selection of software matrix. In the proposed model, defect of software is predicted based on the measure present in the early phases of SDLC. Therefore, proposed model leverages the most reliability relevant top matrices from the early phases of SDLC. Second is define membership function. There are many methods of membership value of assignment such as rank ordering, intuition, inferences. Membership function can be variety of shapes like polygon, trapezoidal, triangular, and so on. However, a triangular and trapezoidal shape provide a convenient representation of domain expert knowledge, and it also simplifies the process of computation. In membership function actually defines the overall characteristics of the matrix. It has the, if I will show you, this part is known as core, this part is known as support, and this part is known as support. In the core part, the membership value is maximum 1. In the support, it varies from 0 to 1. Yeah, I've used them both triangular and trapezoidal. These are already built inbuilt fuzzy tools in the MATLAB. I use it. Input of the matrices. These are input. I show you one case study.
Yeah, come here. That's better for the audience.
Yeah. For the,
One more. You wrote something psychometric complex.
yeah, I have taken supplementary complexity and input in the design phase.
Come to that file.
This case is
You have a Is this complexity useful for you?
yeah, it can be useful, sir.
Not can be. It is not a complexity working.
Okay.
You don't have a system of the development.
Yeah.
To some extent, you are using the
System software. Okay.
But the commercial of the development is doing, you don't use the problem. Neither program nor half.
Yes, sir.
You always have the scripting language or operating system. And in both, systems. How can you have your conditional psychometric? You should have a complexity to be used by you, which is object oriented.
Okay.
Otherwise, it is a fuzzy field. क्योंकि जो हो नहीं सकता उसको लेके काम शुरू कर दो तो maybe your guidance happens. But ultimately, you are doing PhD, you don't want to come to academic.
Yeah.
Once you come to academic, you have to do it.
Definitely.
And वो जानते क्या बोले? ये सारे ने कुछ नहीं किया, तो अपने PhD में एक psychometric complete किया. You cannot earn respect, you cannot command people. You don't do it. You can take some metrics like, example,
Chitambram camera matrix. Object oriented matrices. Yes.
After that, you have metrics from market, you have metrics from model. There are some various aspects of object oriented language. What is relevant?
1 minute, sir. This is the, I just taken the value of the matrices in the, these are the results. Actually, I am predicting what are the effect of matrices in the various phases. From the table, this one, it is clear that defect indicator in the requirement phase is 26%, defect indicator in the design phase is 20%, and defect indicator in coding phase is 12%. From the literature, it is clear that maximum number of defects occur in the requirement phase, then it propagates into defect design phase, and then it propagates to coding phase. The maximum number of defects occur due to only requirement phase. That's why it is 26%, then it is 20%. It is decreasing order. If you compare with the earlier work, Pandey and others, and my work, in the Pandey work, they propose only 10%. Yeah, I have. Fourth one.
So this is where is published?
What's that?
Where is this paper published?
That is International Journal of Electronics Engineering,
Volume 1.
Volume 1. Yes, sir. Number 2.
I just comparing with
Actually, I am comparing with the other modules, that is SUMA, V and Gopal Krishnan Nair, defect management strategy in the software development recent advancing technology. It came in 2009. He told that the maximum number of defects occurred. This is the recent advances in technologies.
which match, which where has it been published?
Yeah, come here, sir.
अगर यार काम फर्जी कंपैरिजन फर्जी दिक्कत में आ जाओगे समझ रहे पुरता में इनपुट है 18,000 को पुरता में क्या वर्क क्यों शर्म आती है अपना एक जैसे कोई सॉफ्टवेयर है ओपन सोर्स सॉफ्टवेयर कंप्यूट द कॉम्पिटिटिव बाय योर why did somebody else find the fuzzy values? They are very incorrect. These papers are rubbish. If you compare the results with some paper published in IEEE transaction, transaction, LPA journal, PJ journal, it's still okay.
Yes, sir.
But this is right. I think something
No, thank you.
the guide for share for this, so very much. Fine. Any question from all of you? Anyone?
Okay, sir, thank you.
Yeah, function if I have presented. Yeah, depends later things. Usually I'll press function if I. Yeah. Good morning, Mr. Professor Kushwaha, Mr. Jainath, and esteemed researcher. I'm Prem Kumar Krishnamurthy. I'm doing my BTech third year in VIT University Chennai campus. I'm here to present my proposed SDLC model. SDLC, Software Development Life Cycle, which describes initial feasibility study through maintenance of the completed system. Actually, SDLC is the backbone of software development. SDLC phases include requirement collection, analysis, coding, testing, deploy, and maintenance. There are many life cycle models, and each one has its own merits and demerits. What I have in my mind is, if I would be able to come up with process model which avoid demerits of existing model and incorporate merits of those models. Before proposing this model, I have just 3 goals, which are: my model should cope with continuous changes and requirements, follow step-by-step process, deploy the product in single iteration. As the term copes with continuous changes in requirements, we able to understand. So whenever in a project development, if in the current rate, the everyday requirements are changing. So my model will accept the continuous changes in the requirements, which incorporate new requirements and make it as a module in the developing system. And step-by-step process. Even in manufacturing unit, also industries also they are following step-by-step process. Usually, step-by-step process means first we'll do feasibility study. For example, if you are going to develop a software for online education, first we need to see what and all existing online education tools available, how they are doing, how the system is there. So that will come under feasibility and requirement collection from the client, from the vendor. Then we'll do analysis, design, coding, testing, deploy, and maintenance. This is the proper format to develop any system. Actually, even professionals are preferred to do their project in step by step. So the guarantee of the success will be more if you follow step by step process. And come to my third goal, my product should follow single iteration. So if you start develop your project and it will keep on taking many iterations to complete your system, finally you'll end up with in practice, I mean the current practice which are not following will be added in the develop the system. So and also it will take more time to came up with your product. So my the third goal is my model should follow should deploy the product in single iteration. So I came up with the model called I approach. So here it will follow first goal it should copes with continuous change and handle the new requirement. Will follow regular like requirements collection, analysis, design, coding, testing, deploy, and if new requirements comes, yeah, that's what I've said in new requirements. We can mention here. Yeah, still my model have one constraint, that is the new requirement should be dependable of existing model. I'm still working for that. So if new the client intimated new requirement, it should be so, that's what I mentioned, sir. It should be dependable requirements. So yes, sir. For example, I've collected my requirements, I've done my analysis, I'm doing design, sir. If new requirements come, I'll do for analysis design. Yes, sir. If it is comes for testing, I mean, as of now I'm in testing and new requirements comes, simultaneously a team will have to do their analysis. Yeah. So, but we are doing simultaneously, sir, and also, as I mentioned, it is a dependable requirements. If it is dependable requirement, will be easily to do all this analysis, design, coding, sir. But if it is new requirements, completely different package or model they want, then it will be difficult to incorporate those requirements. That was the constraint, and still I am working for that. I'm planning to propose a metrics. So if up to this level you can go for development, incorporate new requirements. So that thing I'm planning. I mean I'm working on that, sir. Yes, sir, sure. So as the three goals, it follows step by step and incorporate new requirements, and it will deploy your product in single iteration. There are a few features which motivates you to go for I approach. That are product can be delivered in a short span. guarantee of success confirmed by following step-by-step process, and it's easy to implement, and cost will actually 1 minute, sir. Actually, I worked for this to design a model which satisfies these 3 goals, sir. So I've designed, but later I found that it came up like I, so I named it as I approach. Yes, sir. I've worked. It took me almost 3 months, sir. So so the model should able to handle the 3 goals. So once I've designed, I found that it came like. Yes, sir. In testing, software testing is there.
Then you cannot grow. That's what it is about.
Yes, sir.
If it is around you want, you're not saying that I am not around. What you can do? You can develop it quick,
Yes, sir.
get it done, and test that immediately.
Yes, sir. Sure, sir.
Second, you have to take care of the data.
Yes, sir.
Like you are still studying, you have ample time.
Yes, sir.
What should bother is, how can I first create the image over the answer?
Yes, sir.
So that if I am at testing phase, I can at least import and export of this, which are the major form of
Yes, sir.
does it work before?
No, sir. I'm still working. Actually, last 8 months only I've started this. Well, actually, I had a subject like principle of software engineering. There only I've came across those model regarding software engineering. I've gone through all the details, sir. So while studying that process model, I've thought there are this merits, demerits, and also I've planned to this things. What I in the future work, what I planned is to implement metrics. So which tells first time if up to this you can go with I approach or other with existing model, and also in future you should the model should incorporate new requirements at any time, any level, even it is dependable or no independable. So I'm not sure, sir, but
Why you are developing metrics which are based on the sector?
software requirement specification. Yes, sir.
Because if a company can get all the information about the software usage from there.
Yes, sir. Yes, sir.
It is good for you.
Yes, sir. Sure, sir.
If you do it as after design phase of what is there, then you join the pipeline and all of
Yes, sir.
during for the travel phase, you only have to
Matrix. Yeah, sure, sir. I'll once I'm back to there, I'll work on this, sir. Surely. Yeah, and that's it.
and you have one general